So, food production and the environment. So obviously, going to talk about today is, really our basic needs: food, water, shelter. I don't know. What do you think? Maybe a Nintendo? Is that a basic need? I don't know. But those are the basic things, and we know that food production is probably causing the most damage. It causes the most stress. So remember, we're using that part of our natural capital, especially our soils, and we're going to have to use it to feed all these people that we have in the world. So next slide, please. Okay, Elder Leopold, 2 spiritual dangers. Not owning a farm, one is the danger of supposing breakfast comes from the grocery store, and the other that heat comes from a furnace. So we're very fortunate up here in the Mojave Desert. For most of you, you at least have animals in the backyard. You kind of know that, milk comes from a cow because you kind of understand how mammals work and that kind of good stuff. But you don't really understand how that milk gets to your table. And so we're going to look at that when we go out to the dairy at the end of this thing. You're going to look at some of those challenges. What does it really take, especially given the very stringent environmental laws, to make that happen? Because in California, for us to do this, the farmers have to overcome a lot of environmental regulations, which are a good thing, right? So last week, anybody see an article in the paper last week at all? Does anybody read the newspaper? Not many people, right? But there was actually a article. There's a new law just come out that I need to research, and some of the boys that enjoy this kind of stuff. So cow fat flatulence, ruminants, flatulence. They've just brought out a new methane law. Methane is a serious global warming gas. Heard everything from 25 to 35 times worse at greenhouse gas. The ability for it to keep those infrared rays inside, just like the windows on your car do or a greenhouse does, 25 times worse for methane, CH4. Am I right on that, Mr. Huffman or Mrs. Thing? I think it's CH4. Yeah, okay. CH4 does that 25 times better or worse, depends which way you're looking at it, than CO2, carbon dioxide. So lots of work these days. We're going to talk about it as well when we come to composting and all that later, that we should keep that stuff from getting in our air. So, okay, next one. All right, so big thing here is food security. We don't really know what this feels like very much. Unfortunately, some of our inner city people probably do. Just having daily access to nutritious food to live an active, healthy life. Okay? Know that the main nutrients are macronutrients, carbohydrates, proteins, and fats, and then micronutrients, vitamins and minerals. Probably about 40 in our diet are needed. You only need really little parts of it. You need a little bit of copper in your diet. So, but if you don't have it, it causes just as much problems as if you do have it. Okay, food insecurity is this idea that you're chronically hungry or you chronically have poor nutrition. We're going to look at that. That's kind of different. You might be hungry, but you might actually be nutritionally okay. So, you miss lunch or something. You're hungry, but you don't have poor nutrition. You're not missing out on one of these nutrients. Okay. Root cause is poverty. We've gone over this a lot. So next slide. The whole trick here is, are we going to, by the way we operate in agriculture, in food production, are we going to do some things that are going to bring hope, or are some of these things just illusion? And one of the things we're going to talk about a little bit later is genetic modification. So they took rice and they genetically modified it, genetically engineered it to produce more beta carotene, which in turn is the precursor for vitamin A, which in turn prevents people from having a lot. Vitamin A is a basic mineral. A vitamin helps with lots of things, but one of them is night blindness, right? So especially in young people in parts of the world without vitamin A. So what a great way to do it if your staple grain, the thing you eat most of, has one of the things that your diet is potentially deficient in. what a great way to do it. Now, but that brings up, does that make it ethically okay to do genetic engineering? So now this is where the whole ethical side of it kicks in, okay? Is this the right thing to do? Is this the smart thing to do? Is that a good way to use that technology? Or the question would be for a lot of, we don't want to use that technology at all. We'll talk about that a little bit in a moment. Next one. Okay, so chronic undernutrition is hunger. We talked about that. Chronic malnutrition is when we lack one of those nutrients, those basic nutrients. And this is an example of iodine deficiency, which causes goiter, which causes the thyroid glands to swell up like this. And this is chronic fatigue, pregnancy issues, all kinds of problems with this. Your thyroid gland is what governs your metabolism. Okay, so things like thyroxine, the hormone thyroxine, speed up your metabolism, and if you don't have it, slow it down. So how fast you digest and process those nutrients we're talking about, okay? Iron is another big one, and we already talked about vitamin A. But there's lots of other ones, okay? 1 in 6 people in less developed countries have a malnutrition or undernutrition problem. This is a really happy story, actually. We've come a long way in hunger and nutrition across the world. We've actually helped a lot over the last 20 years. And the green revolution we're talking about in a moment has helped with that. But still, that's way too many. Especially when we'll notice in a moment, it's the kids and often the women that suffer in this area. Next one. Okay, overnutrition. This is a first world problem, right? And we're coming right up against this guy right here, this ugly Halloween thing here, my least favorite holiday. Sorry, just the way it is. But, you know, we suffer from overnutrition, and this causes just as much health problems as undernutrition. In fact, you know, things like disease and illness, life expectancy, quality of life, and it costs 2 times the cost for us to treat overnutrition through all our diet pills and our exercise programs. I did my jumping jacks this morning. I'll just tell you, I can show it. Old man still can do that. So I did my, I don't know, what's the lady's name who did the Biggest Loser program? Jillian Michaels. So my wife and I turned that on at an unusual hour of the morning, and we did Jillian Michaels for 20 minutes. Actually, pretty good stuff. But we have an overnutrition problem. Next slide, please. Okay, so we need to look, and so basically, how ridiculous is that? What we take to solve our overnutrition, I think I had this, it's 42 billion they estimate in first world countries to solve our overnutrition problem. Take 24 to completely cover undernutrition and hunger. Okay, malnutrition and hunger. So that just doesn't make sense. What are we doing? Why is that? Okay. So next one, this one is some guys out here, children, literally hunting for ants in the Sudan. And this is not a made-up picture. This is very real. You can see that the natural landscape here is starting to go to desert, a process called desertification. When things are overgrazed and overused, you can actually see the cattle in the background there. And so what this actual key question in our key concept, this is one of the ones that you're going to do your expanded definition is, what are the greatest obstacles to producing enough food? Well, they're poverty, war, climate change, and the environmental effects of industrialized agriculture. We'll quickly look at industrialized agriculture in a moment. We have several other classes in the program. In fact, for the Lewis Center, your class that we teach, going to teach you in the spring, AGNR 175, looks at that, and also the ethical issues that go with that. But this is the major ethical issue. If we're causing industrial agriculture causing this kind of problem, then we all should be rethinking. That's a major ethical issue. Okay, these guys have an interesting disease, just so you can notice, is they have a thing called kwashiorkor. Very, very prevalent in parts of the world where they don't get enough protein. This is a protein deficiency. You can see this poor guy actually has got muscle wasting, just like you'd have in concentration camps. Body is actually using up its own protein, but then they have this big belly, which is just a sign of this disease, this protein disease called kwashiorkor. And we saw a lot of that in South Africa. In the native areas right close to where we lived, we'd see that. And so those kind of images are really burnt really deep in my memory, and kind of part of what drives me to want to teach people about this stuff. Because we could just do a lot better. There's really no excuse for that. So next slide, please. Food production has increased dramatically. The systems we use for food, let's quickly look at that. Croplands, right? So we've already talked, I think in this class, really 3 staples for folks, depending on where you live. It could be rice, could be corn, or it could be, which one? What can I even think? Rice, corn?
Beans. Soy.
No, it's what is it? Oh, wheat. Wheat. What wheat? Wheat. Your Wheaties. So wheat. So depending where you live in the world, those are your staples. But the problem is, in case you don't know, all of those are too low in protein, right? Somewhere between 8 and 10%. Normal people, we adults probably come close to getting away with that, but we should have about 12%. So they don't have enough protein. But those are the croplands where we grow crops, right? 77% of our food is from crops, and it's 11% of the world's land. Rangelands, pastures, and feedlots. Now this is for meat and milk products, things like that. 16% of our food on 29% of the world's land. And this is a big controversy because a lot of people saying, you know, just stop grazing all those cattle. They're causing all these cow farts that we're talking about. It's a bad deal, you know, all that stuff. But a lot of this ground can't be used for crops. It's not arable. It's not flat. It doesn't have good soil. It's the kind of land we see around here up into the San Bernardinos. That's rangeland. And the ruminants, cows, sheep, goats, can eat that food, that very fibrous food that we can't digest. They digested it and they break it down into usable glucose and carbohydrates, right? They can actually metabolize that. And then the last part is aquaculture that produces 7% of our food, okay? Tremendous increase in global food production. Next one, please. Industrialized agriculture is high input. So this is what also we call factory farming, responsible for 80% of the world's food production. Okay, so industrialized agriculture, 80% of food production. But now we're also going to look in a moment at a map of showing where does that happen. Well, it happens in the wrong places. It happens in the San Joaquin Valley, just over the hill from here, Bakersfield up north. But then all that extra food has to get shipped somewhere. And we're going to talk about how that costs a lot of money and it's hard to do. Why is it hard to produce enough food? Because of war and strife. So when we ship that food, the United Nations and the US is very good at doing this, but we can't get it to the right people because the warlords or the chaos or the wrong tribe gets the food instead of the people that really need it. Okay? Forms of agriculture, plantation agriculture, when you actually plant bananas or bananas, and those are used for cash crops. So if you're in agriculture, we're going to talk about subsistence, just growing enough for yourself, or growing enough to sell. So these plantation agriculture are generally in less developed countries. We've also seen huge numbers of greenhouses. If you go down to Baja, California, a lot of our vegetables produced there now, especially our tomatoes, and they have a lot of greenhouses down in Baja these days, especially the middle part of Baja. Next one. So, high input means we're going to put lots of fertilizer, big tractors. Farmers love tractors, right? They love these things. This is what farmers dream of doing, is tilling the ground, plowing the ground. But we're starting to look at different ways of doing it. Sustainable agriculture says, let's leave the crop that was there, and let's come in and just inject the seed in the old stubble. This was probably a wheat field or a corn field that's been harvested, and they've come in here with some, looks like some kind of vegetable crop. Okay, so that's lower input. So we can be more sustainable even in the industrial agriculture. There's a lot of things we can do to be more sustainable, not have all those high inputs. Because obviously when we've got high inputs means we're using up our natural resources faster. Next one. Monoculture, the concept that we I think talked about, I get all my classes mixed up, but monoculture is where we grow all the same crop year after year after year. And what that does is it basically makes the crops more susceptible to pests, because the pests are like, woo, yeah, I like corn, I like that particular strain of corn, and I'm going to get really good at eating that stuff. It also makes it very bad for nutrients, because monocultures use the same nutrients. So then we can deplete our nutrients. And so a lot of our food today is actually depleted. It's great to think you're going to get everything you need from your vegetables and a good healthy diet, but if it's grown in a monoculture, you might not be getting exactly what you think you're getting in terms of minerals, because those crops year after year will, depending on the crop, will deplete certain of those essential nutrients out of the soil, certain minerals as well. Okay? Very, very high input. This is a situation here where we've got beehives coming into what looks like almonds, and that's very high input. Those bees are kept normally in the northern part of the United States and in Canada, and they're shipped into the San Joaquin Valley every year. You can see them coming in big trucks to pollinate. Okay, here's more of a polyculture. This is a more sustainable method where we grow a whole bunch of things together, and that's better for the pollinators. We encourage more natural pollinators and more diversity. It also encourages the beneficial insects, okay, the ones that eat the bad insects. So this is a much better balance. And we also plant things next to each other that help fertilize the soil. So just going to throw this out. There's plants called legumes, like beans or soybeans, right? And they actually can fertilize the soil with nitrogen. They can actually capture nitrogen out of the air, and they have little bacteria and nodules on their roots that actually fix it and make fertilizer. Nitrogen is one of the main fertilizers, one of the main nutrients that plants need. That's how you get nice and green and leafy and all that good stuff. Okay, next one. Okay, main types of low input polycultures or low input agriculture. Traditional subsistent agriculture. You're only growing enough for your own family. Human labor is what you've got. You don't have tractors, you have draft animals, and you're just growing enough for yourself. Traditional intensive agriculture is more, think about China, Japan, Thailand, those terraced areas where they're growing a lot of food and they're also producing for sale and for other people, okay? And they increase the higher use by using manure, sometimes human manure, by the way, and water. So they're irrigating in some way. They're getting water to those. Polycultures has some of those benefits over monoculture like I talked about. It's more diverse. The plants are healthier. They use different nutrients. It's better for pests because it balances things out. So polyculture is important. Poly just meaning growing lots of plants at the same time. You guys all heard the famous story, and it's not just a story, it continues today, but in our local Native American culture, they grow the three sisters, right? They grow their corn, their beans and their peppers together. And for example, they all kind of coexisted together, but the corn provides a nice growth, kind of a trellis for the beans to go up. The beans are a legume, so they're putting nitrogen in the soil. And then I don't know what the peppers exactly do, but again, it's a polyculture. So they all balance each other out. Okay, so that's a polyculture. Next one, please. Traditional agriculture relies on low input polycultures, and sometimes we kind of, I'm just going to use the word cheat in the sense that we cheat on nature. So we've got all these nutrients. This is a very nice tropical rainforest here, and this is what we call slash and burn, right? We come in, we cut that down. Helps now that we've got big old chainsaws that people can get to, and we literally burn all that biomass, and the nutrients go into the soil. And that's going to only last a little while, 5 to 7 years, and people are going to come in there and grow many different crops, but because it's the tropics, those nutrients, which are water soluble, are going to leach through the soil. They're going to go beyond the root zone, and so after a while, this is going to become a pretty impoverished area. And then these are the areas that we're going to have soil erosion, we're going to have invasive weed coming back in, and if we're not careful, the soils become so disturbed that even the tropical trees can't grow back. And that's what we don't want to do. Better thing to do here, if we're going to do agriculture, would be come in, thin out the really good trees, some sustainable forestry, take out the trees that we really wanted to use and we could sell, and then plant in between it. So let's say this was a coffee area, we then would have shade-grown coffee, and then all you Starbucks addicts would be really happy, right?
I don't know what you're talking about.
Huh? There's a Starbucks right here. She's hiding it right now. Okay. So reduce soil erosion with slash and burn, but ultimately more soil erosion, less need for fertilizer and water because we're allowing that organic matter to go in there and hold water, but this all cycles through pretty quickly, and so this is something we want to get away from. Next one. Okay, so looking at the soil, we're not going to do, we have a soil science class here. It's a very key class for us, really important class if you're going to understand how ecosystems work in general. But this is just a profile of a soil, and what we're looking at here is, again, one of the key sustainability pieces here, which is, let's throw this out to somebody out there, Granite Hills. Guys, what main sustainability mechanism are we looking at here in the soil? There's several, but remember the 3 sustainability principles? Which one are we mainly looking at here when we're looking at all these little bugs and bacteria and fungus in the soil? This living biota that's in the soil.
Nutrient cycling?
Beautiful. Awesome. So it's cycling phosphorus, it's cycling nitrogen, it's cycling carbon, right? It's breaking down all that humus, all that organic matter, and releasing carbon for the plants to take up and then take and use again, right? And all the nutrients. So yeah, chemical cycling. Very important also biodiversity, right? We want to keep these soils healthy and biodiverse because we need all these different bugs to make a soil. They say that a centimeter by centimeter cube of soil can have thousands upon thousands of living organisms in it. Soil is not dirt. That's what the soil scientists like to tell you. Dirt is just little pieces of rock, sand, and smaller silt and clay. But a soil is a living ecosystem. So there's a whole science in how to maintain that and keep that healthy. Okay. So next one. Right. The Green Revolution. First one we talk about is when we got good at doing industrial agriculture. We started hybridizing rice and corn, making them be high yield. We breed the best, what we used to say in the horse breeding business is we breed the best to the best and hope for the best. But you hybridize, you pick your best corn and you breed it to your other best corn, and you cause hybridization, selective breeding. Then after that, we came along with, that was the first revolution, and now we start having tractors and we have high energy input. We start using chemical fertilizers made in a factory instead of being natural manures and compost. Then the second green revolution really came out of California, mostly out of Davis, where they started using genetic modification and fast-growing dwarf varieties, especially rice. So, rice, again, we focus in on those staples. If that's 77% of our food and people are under nutrition or starving, makes sense that we would focus on those crops, those staples, those grains, right? The grasses, they're actually grasses, wheat, corn, rice. And that was the second green revolution starting in the late 50s and 60s. And we actually tripled the production of world grain. Again, it's in the wrong place. We have to ship that all over the world and hope that it gets to the right people, gets to the hungry people. Okay? There's a distribution problem. Okay, next one. Right, so this is looking at world grain production going up, but unfortunately, so was the population. Mm-hmm. So the curve is basically evened out. We're almost back, per capita grain production, almost back to where we started in the 1960s. Okay? Because we've had that exponential growth of people, right? Next one. Agribusiness, average farmer feeds 129 people. That's good. Food production, very efficient. This is an interesting thing to look at, how fortunate we are. I think this is something that's going to change. But Americans only spend 9% of their income on food, unless you're a foodie and you go to fancy restaurants. But you're very low. Whereas in the other parts of the world, it's 60, 70% because that's what they need. They're so close to being under, hunger and undernutrition. They spend a huge percentage difference in how much they spend on their food. Okay, we get our food really cheap because there's some hidden costs, subsidies. For example, in California, our water systems are subsidized. The farmers don't pay what it costs to put in all these aqueducts. We've got one of California's major aqueducts running right through our valley. So let's ask the AAE, what's the name of that big aqueduct up there in the area that runs from, it actually comes from the San Joaquin Delta, comes from San Francisco. What's the name of that project? You guys know? State water project. I'm not asking Granite Hills because you guys, especially the SCADA folks, you know that. But how much, let me ask AAE, pick on you guys again, how much of our water comes from that state water project? That massive river that runs through Hesperia. How much of our local water comes from that?
One student said 70%.
Okay. Sorry. Zero. Buzzer. Bad buzzer. Okay. Actually zero. In indirect, we get some water from that we put back into our underground, but all your water that you access today will be pumped up from underground. We store it underground and we pump it from underground. So technically, zero of our water comes from that if we're talking daily use directly. Okay, so there's hidden costs. There's also the hidden cost of the pollution and environmental degradation that's going on. We'll be looking out at Hinckley. We'll be looking at nitrates. Nitrates cause baby disease. They cause mental retardation, and they come from feces and urine of cattle, and from us, actually, if that was the case. They can get in the groundwater. And so there's a big project, a big crisis in Hinckley with the dairies out there of are they causing more nitrates to go in the water for the people of Barstow? And we'll talk about that a little bit. There's some pros and cons and very much two sides to that argument. Okay, next one. Practice of conventional agriculture. So intensive tillage, right? We saw those big tractors plowing, doing all that stuff. We tear up the soil. When we tear up the soil, we make it more prone to erode, and we also we break up its structure. It actually has a structure. It holds together with all that organic matter. Monoculture, we talked about that. Water use, irrigation, we'll be seeing some fancy irrigation systems. Application of synthetic fertilizer rather than manures and compost and natural fertilizers. Chemical pest control. Chemical companies like DuPont got very fancy and they came up with some really fancy ways to control pests, right? We looked at one of them, which was DDT, right? And the effect that had on the large raptors. Genetic manipulation of crop plants, make them more productive. Those dwarf varieties grow fast, still produce really well. Confined feeding operations. Granted, what is a confined feeding operation? Not when your mother locks you in the room and throws you tacos or something. What is it?
Isn't it when they force cows to eat? Isn't it when they force cows to one type of food?
Yeah, close. Cows, dairy cows, we'll be looking at confined feeding operation for dairy. You put all the cattle in one place and you bring the food to them, rather than the cows going out on the range or going out on pasture, which is grasses that you use to get their food, right? Feedlots, so when you put a bunch of cattle in there to feed them up before they go to market, to get them up to market weight, that's a confined feeding operation. That can cause a lot of pollution, and it also can also have some real positives. It's a very efficient way to do it. Energy use, we talked about that. So let's keep going. First revolution, crossbreeding and artificial selection. I talked about that. That was the first gene revolution. The second gene revolution was genetic engineering. Now we're actively taking genes from other plants and animals and combining them to get better production. So we're into the age of genetic engineering, and we all need to know what a GMO is, right? It's not the new kind of Chevrolet, not the GMO with the full, you know what, I'll stop there. Genetically modified organisms, got to know what those are. Big, huge ethical issues. Okay, next one. All right, world meat production increased sixfold between 1950 and 2010. This goes back to economics. China, India, lots of places that are expanding very fast economically. First thing that people want to have is better food. They want the dairy products and the meat and all of that stuff. And so that has driven it. And so we also are very, very, very focused on eating meat. We eat way too much protein. That's one of our overnutrition issues, right? The limiting factor, that's like we talked about limiting factors, for any kind of population is the land. So in agriculture, especially in meat production, is the amount of land. It takes a lot of land to produce meat. Remember we talked about it was only like 11% of our food comes from meat and protein sources like meat and fish and all of that, but it takes 29% of the land. And we're running out of land to do that. And some of the land we were doing on that is being degraded. Like you're looking at those poor little guys hunting for ants there. That land used to be a grassland. You can see it's pretty much denuded. It's pretty much going towards a desert. And once it gets to be a desert, in Africa there, the Sahara Desert is moving something. Do you remember the number, Mr. Hafan? Pike, but something like 25 miles a year that the Sahara Desert's moving south. It's quite significant.
Yeah, it's upwards to 30%, I believe, is undergoing desertification.
Yeah, yeah. It's a huge issue. Because the grassland, which are very productive, that's why you see all those animals in Africa, those grasslands are very productive, but they're also very dry. And so it doesn't take much if you don't manage them properly, you overgraze them, too many animals on there, then it can kill the grass, and then you lose the structure of the soil. The soil basically dies, and that's what really turns you into a desert. Once you're at a desert, you've got a problem, because then you don't have all that organic matter, you don't have all those living things in the soil. That's very hard to bring back. Next one.
You don't have to have a desert to have desertification. It's happening in urban mountains surrounding urban areas like Los Angeles.
Right.
When you have fire after fire after fire, you get the desertification of mountainous areas.
Exactly. No, exactly. When you see it locally and all across the West, for us, it absolutely, I absolutely was not fun. Chemicals. So one of the things we're very concerned about industrialized agriculture, and there's a lot of concern that we're eating all this stuff, right, in our food and our water, all the pesticides and all the chemicals, all the hormones that are being fed to animals, or antibiotics that are being fed to animals to help them grow faster. So that's one of the issues of industrialized, very intensive agriculture. Next one. Synthetic fertilizers and pesticides. Just this little sludge is just showing you how this is kind of, if you just give your plant Miracle-Gro, which is just mostly nitrogen synthetic fertilizer, or if it's an organic fertilizer, it leads to a much more balanced chemical recycle, balanced ecosystem in the soil when you have an organic fertilizer, right? Organic, inorganic, organic means it was living, right? Inorganic means it's just produced. Basically what they go out and mine phosphate rocks. Then they have these incredible, nasty, stinky, polluting factories that make phosphate fertilizer. Phosphate is one of the major nutrients for plants. And then you go to the store and you get something like this, 22, 2, and 8, right? First thing it tells you there, how many, those are ratios of the different nutrients. So what does that tell you right there? 22, 2, 8. First thing you should be thinking is, how many nutrients are in that chemical fertilizer? You know those little pellets, white pellets that you put on your roses or whatever? That's a chemical fertilizer. How many nutrients are there? How many minerals? Right? 22 parts of nitrogen, 2 parts NPK, 2 parts phosphate, 8 parts potassium. Okay? So it's just like feeding steroids to your plants. They're only giving it the main nutrients. That other 40 essential nutrients aren't there. So you're going to have a very unhealthy plant. It grows fine, but it's going to be very susceptible to pests and diseases, and it's not going to be as nutritious for you in the end. Okay, next one. Here's a chemical. Go back, please. Wasn't too long ago in Texas, I forget the city's name, they had a big chemical fire in one of these factories. You won't find these in California. One in the Central Valley, but they're so polluting, they put them in low socioeconomic areas, out of the way. So these, and they put them in other parts of the world, right? Bhopal, India was where one of the big, I think it was Pfizer chemicals, one of their factories exploded and killed a bunch of people. But this is a chemical fire from a fertilizer producer. So this is not a happy, nice, environmentally friendly process. Never mind, then all those extra nutrients can get into our soil, like the nitrates we talked about, and then cause other problems for people and animals. Selective breeding and GMOs. We're not going to get into this a lot, but just know, I love this one here. It looks like a cucumber coming out of a banana. So tremendous advantage to this. I'll just say, parts of the world that are under nutrition. Africa is one that's the Gates Foundation is spending a lot of time and money introducing drought-tolerant corn in Africa, because there's an issue there, obviously, with desertification we just talked about, and drought. So there's good uses. But in the United States, I was reading the other day, 98% of our soybeans, 88% of our corn is GMO. When we go out on our field trip, we had a chance to talk to a farmer out there about GMO alfalfa to feed animals. So the ethics is, do we really need that when we're concerned about some health issues? We're also concerned about the GMOs, these genes, and this they're crossbreeding with the native varieties and reducing the biodiversity of the number of different kinds of corn plants we need to be healthy as we go forward. So there's some major issues with GMOs. So do we need them in the United States? Personally, I think not so much. But do we need them in the rest of the world? Yeah, I think they're so that's pretty good. The rest will be online, and we will see you guys tomorrow for Granite Hills. All right, we'll just keep going here a little bit longer with you guys. You've got, what, about another 10 minutes, Mr. Huffman? Yeah? Okay. Right, let's roll through here. Show you some cool pictures. Okay, so here's some irrigation. Here's flood irrigation, very wasteful. The water burns off, leaves behind the salts, can become another major issue in agriculture is salinization, increase in the salt concentration in the soil, which in turn makes it so some of the crops don't grow properly. Here's a drip irrigation system. This is the one we'll see. This is a boom system, very efficient. The water is going right to the plants, very efficient. Here's some of the infrastructure. This is an unlined pond in the San Joaquin Valley that I took a photo of, which means we're just losing a lot of water before it even gets to irrigation. But we've got the most highly developed plumbing system in the world to deliver water for agriculture. It also ends up delivering water to us, but it's very, very sophisticated. It takes a lot of energy. Right here is one of the pumps, and you can see the big old electrical poles there to pump these things. This is a little cross channel that was going that way. Very, very sophisticated system to grow this food. And so we need to make sure that water we do use, we use very efficiently. Next one.
However,
Yes.
however, all of these make a hit on biodiversity because you remember you can't maximize two things. So you're either going to maximize food development or you're going to maximize biodiversity in the rivers where the water should be.
Yeah.
You also fragment the ecosystem. This also encourages the use of carbon and causes problems. So don't get so enthralled with the technology, because in Tragedy of the Commons, there is no technological fix. And if we think there's a technological fix, we're going to have problems. And there are problems that are related to these.
No, absolutely. And this is just a look at the two kinds of systems. Here we have, these are almond trees here. This is this little rodent tractor thing that comes along and shakes the almond trees. You can see all the dust up here. There's a little machine there, shakes the trees, the almonds fall to the ground. They literally come with a vacuum truck and vacuum up the almonds when they're on the ground. So very, very wasteful, very, very high intensity. There's a big truck going away from a field in San Joaquin with tomatoes on the top. So it doesn't stop here, because now we're a culture where we're used to highly processed foods, right? So we're going to take this kind of stuff, probably going to the ketchup processor that's in the San Joaquin Valley, right? So we're going to process that food, then we're going to distribute it all over the place. We're going to send it to the Walmart. We're going to take it from San Joaquin Valley, send it to the Walmart distribution center in the high desert over there on the other side of Apple Valley. Then we're going to ship it back to Fresno in the San Joaquin Valley to to put it in the Walmart store. So as we'll see in a moment, our average food item travels 2,000 miles. Whereas if we grow our own food and we buy local, we have farmers markets, we have community-supported agriculture, which is when a group of people get together and they work the land together. We used to have one of these in Phelan. I'm not sure of its status right now. Urban farming, there's tons of backyards and old lots, and you basically grow your own food. All that goes away. Not only do people get connected with the land and appreciate it and understand their food, when you've grown something like this, you're going to be far less wasteful, but you've also prevented all that waste on energy. Okay, next one. So here we're looking at the world and how we grow food. And this is a really, really important slide because we're looking at, okay, where does this industrialized agriculture, and we've hammered this, I'm not going to hammer it anymore, but look where industrialized agriculture is. Okay? Where are all the people? Boom. And boom. That's where all the people are. South America in a little better shape. The people are a little closer to where they produce their food. So there's a lot of different kinds of agriculture. Shifting cultivation, where we slash and burn, we move to different areas. Nomadic herding, still huge, right? And then of course areas where there's no agriculture. Part of the land just can't be used. And we're starting to reach that point where we don't have new land to move into. We don't have tropical rainforests to cut down with slash and burn. Okay, so there's a land issue. Next one. Okay, greenhouses, this is a quick slide of Spain, southern point of Spain. This is what it looked like in the
All the greenhouses.
70s, yeah, and this is what it looks, aerial photo now with all the greenhouses. Pretty crazy. So, we're definitely, go ahead. All right, so fish and shellfish production, the book gets into this a little bit. Again, technology is really accelerated. Remember, from HIPCO, H stands for habitat, I stands for what, you guys? Invasive. P, population. Other P, pollution. O stands for? What does O stand for in HIPCO? Remember that habitat description, the little acronym? What does it stand for, you guys, in Apple Valley? I'm pointing to you. I don't know if you can see it down here. What do you guys think? What does the O stand for? Mr. O. Do you still have Mr. O there? Mr. Huffon? Don't have
Do we still have Mr. Who?
anymore?
Yeah, Mr. Orsinelli, yes?
Okay. It's not for him, but he's a cool guy. Over harvesting. See, here's a picture of some seine netting going on, some deep, that's actually not that, there's another word for it, but look at the fish that they can produce. This is a side of a big factory ship, and they can over harvest and harvest very rapidly and very wastefully. A lot of this fish, again, is not what they want, and they just throw it away.
That was a hit, by the way.
Kill it and throw it away.
Didn't pick it up, but you're going to be expected to know that.
Okay, so aquaculture, we'll probably just end with this. Aquaculture is fish farming, right? So all over the world, whether it's in freshwater situations, where they're growing tilapia or something like that, or whether they're growing tuna as they're doing down in Baja in these big open cages that are out in the water. You'll see these big circular ring cages as you drive down towards Ensenada. But we're actually growing the fish because, again, we have to match the food source that people are looking for. We're not going to be very successful if we want to be more sustainable and we ask people to completely alter. That's not going to work. All right, you guys, take care. Good week.
Thank you.
Take care. We'll see you tomorrow. Okay, next one. Okay, so an aquaculture. Yeah. Mike. Mike.
Oh, you told me. No.
Yeah, it's
This one.
Oh, they almost passed the lower one.
all right, so, let's keep going then. Whoa, why did you get, I can't even see the slide now. What
Oh.
happened? Okay, hit enter.
Hmm?
Hit enter for the slide.
Oh,
New slide.
no.
All right, let's stop there. You guys can see, we'll pick some of this up tomorrow.
This one up.